For our next example, let's evaluate the limit as x goes to 0 from the left of cotan of 2x times sine of 6x. So if I consider cotan of 0, well, cotan has an asymptote at 0. Looks roughly like this. So on the left of 0, cotan is going to minus infinity. And sine of 0 is 0. So ultimately we have a 0 times infinity indeterminate form. And we want to use our cute little algebra trick. I know that a times b is the same as a over 1 over b. And so maybe I'll flip the cotan. So I'll leave the sine 6x in the numerator. 1 over cotan is the same as tan. So in the denominator I have tan of 2x. And sine of 0 is 0, tan of 0 is 0. This is a 0 over 0 indeterminate form. So now I'm free to apply L'Hopital's rule. Remember, L'Hopital's rule only makes sense for 0 over 0 or infinity over infinity indeterminate forms. So the derivative of sine of 6x is cosine of 6x times the derivative of 6x, which is 6. And the derivative of tan of 2x is secant squared of 2x times the derivative of 2x, which is 2. And now, if I rewrite limit as x goes to 0 from the left, 6 over 2 is 3, and then I've got cosine of 6x divided by secant squared of 2x. Direct substitution tells us this must be 3 times the cosine of 0, which is 1, over secant of 0. Well, secant is just 1 over cosine, so it's 1 over 1, which is 1, and squared. Ultimately, our final answer is 3. So here, we've seen an example where 0 times infinity is 3. This is what we mean by indeterminate form. There really could be any value for a quantity that in limit is 0 times infinity. We can't tell just by looking at it. We have to do the work to find out that this is not 0, it's not infinity, it's 3.